Hello, welcome to Unit 4. I've had a question in Lesson 6 about Part 2, Question 25. So we have a rectangular field, and it has to have an area of 100 meters squared. All right, so this is your typical agricultural conundrum, is making sure you have the right area, obviously. So that, of course, is sarcasm. So it is enclosed by a fence. The north-south sides cost $20, so we must have to put higher fencing on either side. So this is $20 per meter. The east-west sides must be cheaper fencing, or maybe neighbors we don't like, so we don't put as nice a fence along those sides. So we want to optimize so the cost is minimum. So we want to minimize the cost. So we have to come up with a cost equation for this particular scenario. So the cost. We know that this side of the field, I'm going to call it, let's call it length to be wild here, and on the other side we'll call it W. So the cost of fencing will be, our perimeter formula is 2L plus 2W. So that will give me the perimeter. But each side has a numeric value stuck with it. So on the length side, I'm going to have to pay $20 for every meter of length, and I'm going to have to pay $5 for every meter of width. So that means my cost equation is 40L plus 10W. Now, I can't optimize when we have multiple equations, so this is my optimization equation. So I need a constraint equation to help me out. So my constraint equation is going to be tied to the area. So we know the area of length times width has to be 100. At this point, it's pick your poison in terms of which variable you want to isolate. So I'm not fond of W's today, so we'll get rid of it. So 100 over L is my constraint equation. So that constraint equation will be our helper inside the cost equation. So before taking the derivative, I'm going to get rid of my W. So 10 times 100 over L, or I'll go one step further, plus 10 times 100 to 1,000. And I don't feel like doing quotient rule today, so I'm going to go L to the exponent -1. Now I can take the derivative to optimize. So the change in rate of cost with respect to the length of the fence, dc by dl, is 40 minus 1,000 L to the -2. To optimize, we let dc by dl equal 0. 0 would equal 40 minus 1,000. And I'm going to go back to positive exponents, so it's over L squared. 1,000 over L squared equals 40. 1,000 equals 40 L squared. 1,000 divided by 40 comes out to be 25. Well, that's kind of handy. So that means L is going to be 5 meters of length. All right. So L is 5 meters, so there is our one dimension, and when I look back at my original problem, that is what I was solving for. So that's a good thing. Using that, then, I can find the corresponding width by going width equals 100 over 5, which is 20 meters. So therefore, the field will be 20 meters by 5 meters, fairly skinny field, more like a dog run. So hopefully we don't have animals larger than dogs, maybe, for this particular field. Anyway, if you have any questions with that, let me know, and I'll see if I can clarify them.